Hello students. So in the last class we had seen the problems based on what? We have seen the problems based on the two blocks, okay? And I had asked you that I will discuss few more advanced problems, or we can say a little bit what? A better problems on the what? Two blocks, okay? So guys, today we are not going to discuss any concept as such, but we are going to see only what? The problems. And with these problems guys, of course your the two blocks problem handling would become what? A bit better. That I'm hoping. So guys, without any further ado, let's start with some problems, okay? So I'll discuss few good problems today. So guys, let's see the problem number 1, okay? So guys, problem 1, okay? Problem 1 guys. So just a minute. Okay, guys, problem number 1. So guys, the problem is from HCV, okay? It's from HCV only guys. It's a good problem for the concept building. So let's see that problem guys, okay? So here we are having one pulley like this guys, okay? And something like this setup is there guys, okay? 1 minute. Something like this, okay? Something like this guys is there, okay? And the mass of this plank is what guys? Small m. And it is guys what? It is holded by a man, which is what guys? Having mass of what? Capital M, okay? And it is given that the friction coefficient between the plank and the floor is what guys? Mu, okay? Here guys, the friction coefficient is how much? Mu, okay? This friction coefficient is what guys? Mu. So for static and kinetic friction, we will take what guys? The value is what? Mu only. And guys, they are asking that what should be the minimum, find the maximum force that man can exert on the rope so that the plank does not slip on the floor guys. What they are saying is how much maximum, okay, how much maximum force man can apply on the rope so that plank does not slip on the floor, okay guys? Assuming that guys what? That there is a sufficient friction is available between what? The man and the plank guys. Means there is no slipping is happening between what? Between the man and the plank, that we have to assume. So guys, you can pause the video and you can try this problem. I will start solving this, okay? So guys, let me change the marker and then we will discuss guys, okay? So solution guys, if you see guys, always remember when they are talking about guys what? Maximum or minimum, always remember guys, they are talking in terms of what? Limiting condition, okay? They are indirectly referring towards what guys? The limiting condition, that is their target, okay? So guys, here if you see the what I'm going to do guys, I'm going to consider this whole thing guys as a what? System, okay? I'm going to consider guys what? This whole thing as a system, and then I'm going to analyze this problem guys, okay? I'm going to consider guys what? The man and the plank as a system guys, because if you see they both are, because guys the man is not going to slip and these both are guys what? Not going to slide, so their common acceleration in the horizontal direction is what guys? 0. So I can consider them as a what guys? System, okay? As per the basic definition of what guys? The conditions of what? For choosing a system, okay? So guys, here also we can choose them as a what? As a system. Why? Because they are having is what? The same acceleration in the x direction. So for x direction analysis we can consider them guys what? As a system, okay? So guys, here if you see, I'll just make this thing. Okay, let me put a color marker here so that I can show you guys that this is a what, this is our system of analysis. Okay, this is our guys what, system of analysis. So guys, if you see, if I take this what, this part out. Okay, let me guys do one thing. I'll just make here separately. Okay, so 1 minute guys, I'll make this thing separately here so that it would be easy for analyzing this guys. Okay, it would be easy for analyzing this. So guys, if you see here on this man, there is a tension would be acting in the upward direction. How much force it is applying is in the downward direction. How much force it is applying in the downward direction, the same force the rope will be applying what, on the man in the what, upward direction. Okay, I hope you understood this idea. Okay, now guys, the same tension would be what guys, the same tension would be here. Okay, the same tension would be guys, would be here. Now guys, if you see, if I see the friction here, the friction value. Okay, if I see guys what, the friction value that would be available is what, mu into n. So guys, to get the n, what we have to do, we have to analyze that how much normal force is acting here. Okay, this normal force we have to analyze guys. And if you see guys, in the vertical direction, guys, in the vertical direction there is no motion is happening. So guys, we can say the net force in the vertical direction should be how much, 0. So guys, if you see what I can say, I can say that T plus n is equal to what guys, is equal to weight of the plank plus guys what, weight of the man. Okay, it is or not guys, weight of the plank plus what guys, weight of the man. So guys, the normal force that would be acting is how much guys, this is capital M small m into G minus what guys, minus tension. Okay, let's say that would be what guys, your force. Okay, I hope this is settled. Now guys, I can write the maximum friction force that would be acting in the backward direction will be how much guys, that would be mu into what guys, m plus m into G minus T guys. This will be what guys, this will be your friction force. And guys, of course, this should be managing what, the tension force that is acting guys what, in the forward direction. It means what guys, tension should be what guys, less than the friction available. Okay, or equal to this guys. So limiting condition is what, for the limiting condition guys, we will take what, we will take this as a condition. Okay, so guys, if I take this condition, I can get the solution as what guys, mu m plus m into G minus mu T is equal to what guys, T. So guys, what we got mu m plus m into G is equal to what, T mu plus 1. So guys, the answer should be what, T is equal to what, mu m plus small m into G divided by what guys, mu plus 1. I hope you understood guys. So that should be what guys, the minimum force that you can apply on the body, at which guys what, the slipping won't happen, at which guys what, slipping won't happen. I hope you understood guys, I hope you understood. Okay, I hope guys you understood. So that would be what guys, the answer, that how much maximum force the person can apply guys, the F maximum that you can apply so that slipping don't happen guys. So F maximum will be how much guys, that will be this. Okay, that will be what guys, this. I hope this is settled. So guys, this is the first problem that I wanted to take. Now I'll move to the guys what, the next problem. Okay, I'll move to the what guys, the next problem. So the next problem is guys what, problem number 2. Okay, problem number 2 guys. So guys, see this problem. This is I think from some book, I'm not sure, I think HCV only. Okay, this problem is from HCV only guys also. So it's also a good problem, so just pay attention guys. Okay, so guys, see, so here we are having a block. Okay, and guys, from here we have another block that we have placed, and guys, this is what, small m, and this is what guys, capital M. and there is a capital F, guys, we are applying on this. Okay, so guys, the question is what the question says like this, guys: the friction coefficient between the two block system in the figure is mu. So guys, here the friction given between what, guys, these two block is what, mu, but the floor is what, guys, smooth. Okay, means guys, here there is no friction, this is what, guys, smooth. Okay, this is what, smooth. Now it says like this, guys: what maximum horizontal force F can be applied, guys? So let me write down the question, guys: what maximum force F, okay, F can be applied applied without disturbing the equilibrium of the system. Guys, this is the first part of the question, guys. So first let me discuss this first part, and then we'll go back to what, guys, we'll go on the what, guys, the second part of the question. Okay, we'll go on the what, guys, second part of the question. So guys, if you see here, try to understand, it's also a very good question. So guys, if you see here, they are looking for that the stability, guys, what, stability should not get disturbed. Okay, now my question to you is, guys, what can we consider them as a what, system? Can we consider them as a what, guys, system? Answer is no, we can't consider them as a what, guys, system. Why? Because if you see, guys, when it will move in this direction, and guys, if it will move in this direction, this will have to move what, guys, in this direction. Means their accelerations are what, different. Their accelerations are going to be different if they are going to move, and if they are not going to move, their tendency is what, guys, opposite from each other. So guys, we can't consider them as a what, system. Please keep this thing in mind. So guys, here what we have to do, we have to analyze the bodies individually. Guys, what, individually. And guys, what we have to do, whenever, guys, I have told you, whenever they talk about maximum or minimum of force that we have to apply, always think in terms of what, guys, the limiting condition, because they are trying to infer towards what, guys, the limiting condition. Okay, so guys, here if you see, if I make the diagram of the first block, guys, small m, okay, small m, guys, just pay attention. So guys, let's say this is the F maximum that we can apply. I'm applying in the forward direction. So guys, of course there would be some tension will come on the body. So guys, let's say the tension is what, in this direction, and of course, guys, because this body has a tendency to go in this direction, guys, so it means the friction will what, friction will act in this direction, because if you see, guys, this body will move in that case in this direction, so it will apply the friction in this direction on this body, because it wants that this body should also become like, guys, what, this body should also, guys, just a minute, this body should also become like, guys, what, like this body should also become like, guys, what, like him only. Okay, like it only. Okay, that the idea that I have told you, guys, because it is moving in this direction, so it wants that it should also move in this direction. So to make it happen, guys, it will apply the friction what, in this direction. So guys, this thing you should keep in mind, that friction will act in what, in the leftward direction, guys. Okay, so let's apply, guys, the friction in this direction, and this friction, guys, will be how much, F limiting. Okay, that will be what, guys, F limiting, and the value of will be what, guys, mu into n, and guys, n in this case will be how much, mg, small mg. Okay, so guys, this will be what, mu small mg. I hope you understood. Okay, so FL will be what, guys, mu n, that is equal to what, guys, mu mg. So guys, because the equilibrium is not getting disturbed, it means, guys, what, the net force on the small m should be 0 and the capital M should be also 0. So guys, let me write down first for the smaller block the force equation. So guys, if I write down what I'll get, guys, like this, that F max should be equal to what, guys, tension plus what, mu into small m into what, guys, g. That is the equation number 1. Okay, now guys, come to the lower block. Okay, so guys, for the lower block, if you see, guys, if you see, the tension would be acting, guys, what, in this direction, and of course the friction would be acting what, guys, in this direction, because action reaction pair. Okay, and this will be also what, guys, F limiting only, and that is what, guys, mu mg. I hope this is okay. and this is what guys capital M, and this is what guys, this is smooth, this is smooth. So there is no friction here, there is no friction here, there is no friction here. So guys, what we can say, we can say that in that case the equilibrium to hold guys T should be equal to what, mu mg. Okay, so to make the equilibrium guys, to hold the equilibrium, T should be equal to what guys, mu mg. So guys, what we can say, that F max should be equal to what guys, 2 mu mg. Okay, 2 mu mg. I hope you understood guys. Okay, so the maximum force that you can apply guys without disturbing the equilibrium of the system, okay, or the particles guys, we can say that it would be equal to what guys, 2 mu mg. Okay, so that is the first part of the question, and I hope you understood the idea of this question guys. Okay, the theme of this question. Now guys, the part 2 is like this. So guys, part 2 of the question. Okay, so part 2 says like this guys, that if F applied is equal to twice of F max. Okay, is if F applied is what guys, twice of F max. In that case calculate the acceleration of individual blocks. Okay, calculate the acceleration of individual blocks guys. Okay, this is the question. So guys, let me solve it for you. If you want to try guys, you can try this problem. Okay, so I'm going to solve this problem guys. Okay, so see, just a minute. Okay, so guys, of course in this case also what is going to happen guys, the system we can't take them together. Okay, we have to analyze the bodies what, individually. And of course guys, now the sliding is going to happen for sure. Okay, the sliding is going to happen for sure. There would be no chance of what guys, equilibrium. Now guys, if you see, this will move in this direction and this will move what guys, in this direction. Okay, now one important thing guys that you have to keep here in mind, that there would be a constraint relation. Okay, the constraint relation says guys what, that how much it will move guys, how much it will move in this direction, let's say x. So the same x guys, it will move in the left direction. Okay, so guys, it means what, if its acceleration is what, a, this acceleration will be what guys, minus a. Are you getting my point or not? Means if it moves with the acceleration a in the right word, it will move with the acceleration a in the left word. Okay, so this is one of the constraint relation that you have to keep in mind during the solving the question, because you need that relationship. Okay, so guys, let me solve this for you. So first guys, for the upper block. Okay, so guys, upper block analysis. Okay, upper block analysis. So guys, if you see, for upper block, the force guys that is going to act on this body will be how much guys, this is how much, this is 4 mu mg, which is what guys, which is twice of what, F max. Okay, 4 mu mg guys. This side will be what guys, your friction, that is what, mu mg already, because now slipping has started. So this will be what guys, of course it at its maximum, and this will be what guys, tension. So what we can say guys, this block is going to move in the forward direction. So what we can write guys, we can write 4 mu mg minus mu mg plus what guys, tension, is equal to what, small m into acceleration, equation number 1. So guys, what we got, 3 mu mg minus t is equal to what guys, mass into acceleration, equation number 1. Okay, now guys, this is small m of course. Okay, now guys, come to the capital M block. Okay, capital M block guys. So capital M guys, if you see, in on that guys, the tension would be acting in this direction, and guys, friction would be acting what guys, in this direction, that is what, mu mg only. But guys, see, this body is going to move in what, this body is going to move in the left direction guys, with the same acceleration a only. So guys, what I will write like this, that t minus mu mg is equal to what guys, capital M into what, a. That is the guys what, equation number 2. I hope you understood guys till this. Okay, now I'll use the elimination method to find out the guys what, acceleration. Okay, so guys, if you see, 3 mu mg minus t is equal to what guys, small m into a, equation number 1. And guys, t minus mu mg is equal to what guys, capital M into a. Guys, add both of them. Okay, so guys, if you add, what will happen, this and this guys would what get cancelled guys. So what we got, 2 mu mg is equal to what guys, is equal to capital M small m into what guys, a. So guys, the common acceleration, the acceleration by magnitude, we can say the acceleration that we are going to get is what guys, 2 mu mg divided by what, m plus m. Okay, so guys, that would be what, that would be your acceleration of the bodies. The upper one guys move in the rightward with this amount, and guys, lower one will move guys in this direction with this amount. Okay, so guys, this is what, this is the case. Okay, so guys, if you see here, these two problems that we have discussed here, I haven't used any what like the steps that we have discussed earlier. Why? Because guys, here there is no slipping happening, or there is no like the same acceleration or something is happening. So guys, what I did, I have analyzed them with the fundamental concepts and intuition. Okay, so guys, the same way you should also have to solve the problems whenever this kind of a problems comes in front of you. You have to use your basics, you have to use your fundamentals, and if you apply those guys properly, you can get the answers. I hope you understood. Okay, now guys, I'll take one more problem. Okay, one more problem I'll take, and we will see that guys how we can do that. Okay, so guys, this next problem is from, again guys, what, from HCV only. Okay, but this is a very good problem, and I think it's from it's inspired from what guys, Irodov. Okay, so let me write the question for you. So it is the last question from SCB, if I remember guys, from the friction chapter. So guys, problem number 3. Okay, problem number 3. It's also guys what, very good problem. So guys, see the problem. So this is a plank guys. Okay, a long plank, and the mass of this is what is capital M. Okay, there is a small plank guys, and this is what guys, you can say small m. Okay, small m. Let me do this. I'll make a little bit bigger this. Okay, so guys, sorry guys, 1 minute, let me make a plank, proper plank. Okay, and guys, there is a, this mass is how much guys, capital M. Okay, and guys, there is another block. Okay, there is another block guys, small m. Okay, this is what guys, small m, and it has been said guys that this is a what, very long plank or thing. Guys, let me read the question first, and then we will see. Guys, it is says like this: figure shows a small block of mass small m. Okay, so guys, it is talking about this. Okay, kept at a left end of a larger block of mass capital M and length L. So guys, it has given the length of this is how much guys, L. Okay, length L. Okay, so guys, the length is L and mass is what, capital M. The system can slide on the horizontal road. The system is started towards right with the initial velocity what guys, v. Okay guys, they are saying system, the system is guys what, started with the initial velocity what guys, v. It means both particles are having guys what, same velocity. Remember guys, they are saying the system started with the velocity what, v. So guys, it means both particles will be having what guys, the same velocity. Just a minute guys. Okay, so guys, this will be what, v, and this will be also what guys, v. So initial velocity of both them is what guys, v only. Okay, now the friction coefficient between the rod and the bigger block is mu guys. Okay guys, here this is given how much, mu. This is given how much guys, mu, and between the blocks is guys what, mu by 2, and guys, between the blocks it is what, mu by 2 guys. Okay, find the time elapsed before smaller blocks separates from the bigger block guys. Okay, so they are asking the question that how much time it will take to guys what to this block to like come off from this guys what bigger plank. Okay, this is the problem. I hope you understood guys that initial velocity of both the blocks, okay, is how much v. Between the ground and the bigger plank guys, the friction coefficient is what mu, and guys between the smaller block and the bigger plank is guys what mu by 2. And guys of course there is something going to happen which we are going to understand the mechanism. And guys what happens at the outcome, if you see, is what that this is going to come off from what this plank. Okay, so guys they are asking what is the time taken. Okay, so guys let's understand first the fundamental that what is going to happen here. Okay, and then we will solve the problem. Okay, then guys what we will solve the problem. So guys if you see here, if I make the guys what this plank, the bigger plank, okay, just for this analysis I am making like this. Okay, so guys if you see here guys it is having a velocity of how much v. So guys because the sliding is going to happen here at the ground level, okay guys, so there is a friction that is going to act here. Okay, if you guys see there is a friction going to act on this, and that will be what guys mu into what capital M into small m into what g. That is the friction that is going to act guys. And if you see guys, due to this there is a retardation that is going to happen on this body. And guys if you talk about the upper body, if you talk about the guys what upper body on this guys, because the velocity of this lower plank, okay, is going to be slower. Okay, so guys it wants what that this body velocity should also become what guys slower at the same rate. So guys what it will do, it will apply the friction on this body because of its own guys what in this direction. Are you getting my point or not? And this friction will be how much guys, it will be acting mu by 2 into what guys small m into g. Are you getting my point guys? Try to understand this plank, this plank is getting guys what slower, okay, because of this friction. And because guys it is getting slower, so it has a tendency of what to make this body also what slower down. Then only what they can avoid the relative friction, okay, sorry, the relative slipping. So guys to make it happen, what it will do, this plank will apply guys to make it happen guys, what it will do, it will apply on this the friction in the what backward direction. I hope you're getting my point. Okay, so very important thing is guys what finding the direction of friction force in this case. So guys please follow my principle that I have told, that always a body tries to what guys to make the other body which is attached to that to make it's like itself. Okay, so that is the same idea that I'm using here guys. If you see this body is moving with the velocity v, but here guys it is having some retardation, and due to this retardation guys its velocity is going to fall. So guys what it will try on this body guys, that to reduce its velocity also so that the slipping can avoid it. And to make it happen guys, what it will do, it will apply the friction of course in the what backward direction. Okay, so guys this is very important. So now guys if you see, because the friction on this guys is acted in this direction, okay, the friction is acted on this guys in this direction. So using the guys Newton's third law, I can say the friction on this will be what guys, due to this will be what guys in this direction, and that will be what is mu mg. Okay, now guys if you understood this much, then I think we can solve the problem very easily. So guys let me solve it for you. The first thing is what we got the direction of friction force. Now guys what we will write the accelerations of the individual blocks. Okay, we will write the guys what acceleration of the individual blocks. So guys if you see for the plank guys, for the plank, okay, for the plank guys, if you see for the plank guys, it will be what, it will be mu capital M small m into g minus what guys mu mg, acting in the what guys leftward direction, because guys this force is what guys bigger than what this force. So of course guys this is going to happen. Now guys this is equal to what capital M into what guys a in the leftward direction. Okay guys, so if you see it will become what guys, it will become mu capital M into g is equal to what guys, m into a. This is the equation number 1 guys. So what we got guys, m cancel. So guys, a is equal to what, mu g, that is for Planck. Okay, that is for guys what, Planck. Okay, this is equation number 1. Now guys, it is going to move in the leftward direction. Now guys, if I talk about the body of this one, okay, for the block, guys, okay, for the block. So guys, for the block, if you see, this is the friction guys, which is going to act in this direction, and that is what guys, that is, sorry guys, here I think some error we have done it. That is what guys, mu by 2. That is what guys, mu by 2, not mu mg guys. So this will be what, just let me correct this guys. Okay, mu by 2. Okay, this will be what, mu by 2. So let me guys correct this part. Okay, let me correct this part. We have done here error guys. So it will become what guys, it will become mu capital M G guys, okay, plus what guys, mu by 2 mg. Okay, that is what, ma. So guys, what we got, a is equal to what guys, it will be what we can do guys, mu we will take common and g we will take common guys. It will become 2 capital M into small m divided by what guys, capital M. Okay, so this is the acceleration of Planck guys in the backward direction. I hope this is settled. Okay, now guys, come back to the block guys. So it is what, it is acting mu by 2 in this direction, mu by 2 mg guys, and mass is what, m only. So guys, the acceleration of this will be what, mu by 2 small m into g is equal to m into, this is what guys, what, a1, and this is what, a2. So guys, this is cancel. So a2 is equal to what guys, mu by 2 into g guys. This is what, this is also guys what, in the backward direction. Now guys, if you compare these two values, okay, if you guys compare these two values, so guys, a1 is how much, a1 is mu g guys plus 2 plus what, small m divided by capital M. Okay, and guys, this one a2 is what guys, mu g by 2. Guys, you tell me which one is bigger. Okay, of course this one is what guys, bigger. Okay, this one is what, bigger. It means guys, it is lowering its speed with the faster rate. Okay, it is lowering its speed guys, what, with the faster rate, and it is guys relatively what, relatively to the block, relative to the Planck guys, it is losing its speed guys with the what, slower rate. Okay, so guys, what we can do, we can use the idea of what, the relative velocity or relative motion analysis guys. So guys, please pay attention. Now I'm going to put the final stop on what, the solution of this question. Okay guys, so we are just going to conclude the problem guys. So see, initial v relative guys, okay, if you see guys, the u relative, okay, which is what, initial relative velocity of what, block with respect to Planck guys. Okay, so u of block with respect to Planck is what guys, 0, because both was having the same velocity guys in the start. It was given to us, okay, that the relative velocity is the particles were given the same velocity, the system was given guys what, the same velocity. So guys, u relative is what, u of block with respect to Planck is what guys, 0. A relative guys, if you see, a relative, that is what, a of block with respect to Planck will be how much guys. So let me write down here, a of block with respect to Planck is what guys, it is minus mu g by 2, which is what guys, acting in the back direction, minus what guys, mu g 2 plus small m by capital M guys. Minus means guys what, I am showing in the leftward direction as a what guys, minus, and the rightward direction as what, positive. So guys, the a of block with respect to Planck is what guys, it is mu g 2 plus m by capital M minus mu g by 2. So guys, let me solve this a little bit more. So let me simplify this guys. So this will become what, 2 plus small m by capital M minus what, half. Okay, so guys, it will become how much, it will become let me solve this guys. So mu g this will become guys 3 by 2 plus small m by capital M. Okay, later we will see guys how much value, how they have reported, but just for the calculation purpose, this is the guys what acceleration of the ball block with respect to Planck. Now guys we can write down the direct equation that x relative is equal to u relative into t plus half a relative into what guys t square. So guys u relative is what 0, and guys the block has moved with respect to Planck relatively how much length guys, L distance. So guys this is what L is equal to what half a relative is what guys mu g 3 by 2 plus small m by capital M into what guys t square. So guys it will become what, it will become 2L divided by mu g. Okay, and guys what 3 by 2 m by m ka under root guys. Okay, that is what the time it should take. Okay, if I further simplify guys, what I can say, I think it will become what, it will become 4L capital M mu g into what guys 3 capital M plus 2 small m. Okay, that would be what guys the answer, I guess. Okay, so guys that would be the answer. Just let me check once. I think that was the answer only. So I think guys there is, everything is fine, but I think there is some error that we have done it during the calculation. It should not come 3m plus 2m, it is coming m plus m, I guess. Okay, so just a minute guys. Okay, let me see once the solution somewhere if we have done something wrong. Okay, so guys this is what, this is just guys we'll go back once to check it. Okay, so mu m plus mg minus mu by 2 mg guys is equal to what ma. So mu mg plus guys this will become what mu by 2 mg is equal to what capital Ma. Guys a1 is equal to what mu g, we can take common guys, and this will become what 2m plus small m divided by what guys, divide by 2m. Okay, so guys here the error has been observed guys, here it should go what 2. Okay, I'll put as a red guys so that you can differentiate what is happening guys. What this is 2m. Okay, because guys 2 I haven't written there. Okay, so guys the 2 will come here. Now coming to guys what block, so that was fine only. Okay, that is what fine only guys. So now if I write down the guys what the relative acceleration, it will become what guys, it will become 2m. So guys this part, this will be what guys 1. Okay, this will be what guys now 1. So let me write guys, this will be what 1. Are you getting my point or not? And this will become what guys 2m. Okay, this will become what 2m for the bigger block guys, and this will be what mu g by 2. So guys the relative acceleration will be what mu g by 2 minus mu g, and guys here again this we have to correct. So guys this will be what 1, and this will be what guys, this will be 2m. Okay, so guys it will become what, it will become 1, and this will be what is 2m. Okay, minus mu g by 2. So guys if we solve this, mu g we can take common, and later guys here there is what mu g, if we take common guys, this will become 1 plus m by 2m minus what guys half, that is settled. So guys it will become what, it will become half. Okay, this will become what guys half divided by 2m. Okay, so guys now if we take the LCM, so guys here the last step. Okay, here also let me correct this. So guys it will become what, it will become mu g if we take common. So guys it will become 2m. Okay, just let me guys, this will become what 2m, and guys this will become what m plus small m. Okay, m plus small m guys. So guys if we solve this, so let me remove this part guys. Okay, let me remove this part so that we can conclude the final answer. Okay, so guys if you see here, it will become what, it will become, I'll write with the LO guys, so that will become what guys 4 L m divided by mu into g m plus m under root, guys. That will be what the time taken. So guys, that is the correct answer. Okay, so there is a small mistake that I had done in the beginning. Okay, so in the calculation, guys, so please correct that. Okay, and I think, guys, the remaining part is okay. So guys, that would be your answer. Okay, so guys, this was also a very good problem. So I wanted to take some few problems on the two blocks, guys, and I think these are pretty much enough to understand the idea of what to handling the two block problems. So guys, in the next lecture we will cover about what the three block problems I am going to take, guys, which is also what just an extension of what the idea of two block problems handling. Okay, so we will take what three block problems on that, and maybe I'll take few more advanced problems from the Erudov. Okay, so I'll take those problems and then we can wrap up this chapter. Okay, so in the next lecture we will finish this chapter and then we'll start some next chapter, guys. Okay, so thank you, guys.